Hi guys, let's do deepest leaves sum. So we're given the root of a binary tree and they want us to return the sum of values of its deepest leaves. So in this example, we would return 15 because the deepest leaves in this tree are 7 and 8. And so the sum of these values is 15, so that's what we would return. And then in example 2, we're given this tree and we would return 19 because the deepest leaves in this tree are 9, 1, 4, and 5. And so if we add up all these values, we would get 19, which is what we would return in this case. So in this case, because we want to traverse the tree level by level to get the sum of each level, we would do a BFS traversal of the tree. And then we are going to have a sum, like an integer to keep track of the sum of every level, but like we're gonna reset it at every level, so it'll reset to 0 every time, and then at the end we're gonna be just left with the sum of these two, the bottom nodes, which we can return the value of. So we're gonna want to start with our queue for a BFS traversal. And then we're going to add the root into our queue to start the BFS from the root. So, and then from here, we're just going to basically, and then let's initialize our sum, because if in Java, if we initialize it inside the loop, then it's not going to recognize it on the outside when we try to return it. So we'll just initialize it here, but still reset it each time. So then now we're just going to do our regular BFS traversal. So while our queue is not empty, then we'll do our BFS, where we want to keep track of the number of nodes in each level. So nodes in current level is the size of the queue. And then we will reset our sum to 0 each time, because this is the loop for every level, and then we're gonna do a for loop that is going to traverse through the nodes in each level. So for every level, it's going to get reset to 0 in this case. So for I is 0, I is less than nodes in current level, I++, and then we're going to traverse each level. So our node is q.remove, our top node, and then we're going to add our sum to so since it's 0 for every level, then we're going to add, so like the first level, it would be 1, and then the next level, it would be reset to 0, and then we'd get 5, and then it would get reset, and then we would do it again, and we'd get 15, and then we would reset it to 0 again for the last level, and it'd be 15, and then we would return 15. So that's like how this would work. And then if node.left is not null, we'll add node.left, q.add node.left. Same thing for the right node. And then at the very end, we're going to do this for the entire thing, and then we'll return our sum. So, okay. And then I'll walk through how I got this if anybody cares about that. But basically, when we start out, our queue is empty. And then our sum is 0. Okay, so, and I'll just use example 1. So we first add the root up here. So then the queue has 1 in here, and then nodes in current level is 1 because we only have 1 node in the queue. Our sum is still 0, and then we are traversing 1 time because it's for each node in the level. Then sum is going to add to node.value, so that's 1. Oh, and we removed this node, so this is empty, but we store this as a variable in node. So then we add the value to sum, which becomes 1, and then node.left is not null, so we would add that to the queue, which is 2. Node.right is not null, so that we would add that as well, which is 3. Then our next loop, nodes in current level, is 2. Our sum gets reset to 0 up here, and then we are traversing through twice because for each node. So then this gets removed and stored in node. Sum plus equals that value, which is 2. And then we would add node.left and node.right, which is 4 and 5. And then we do the for loop again for our next node, which is 3, because that's still in the same level, because we're traversing through twice for these two nodes. Then we would remove this node, so we get 3. Sum plus equals this value, which is now 5, because 2 plus 3. And then we add node dot left is null, so we don't do anything, but we would add node dot right, which is 6. So now we have 6. And then this is our next level. And then nodes in current level is now 3, because our queue is size of 3. Sum gets reset to 0 here. And then we would loop through 3 times, 1 for each node. Our top node gets removed and stored into this variable node, which is 4. We're going to add that to the sum here. So we get 4. Node.left is not null, so we would add 7 to our queue. Node.right is null here, so we would add nothing here. And then we're going to loop through again for our next node in the level, which is 5. So this is 5, and then 5 gets removed. And then we're going to add that, sorry, not here. We would remove that and store that here. Then we add that to our sum, so this becomes 9. And then node.left is null, so we don't do anything. Node.right is null, so we don't do anything. And then we loop through again for our next node, which is 6. And then for 6, we will store that in this node. And then node.left is null, so we don't do anything. Node.right is 8, so we'll add that to the queue. Then we are done with this level. So then we're at the last level. So we're back up here now. So this becomes, sorry, and we also removed 6 right here. So forgot to do that. So now we have 2 because there's 2 nodes in our queue. Sum is reset to 0. Then we're looping through twice here for our 2 nodes. And then we would remove 7 off the top of our queue. So we get that. Add that to 7 here. Add that to our sum here, which is 7 now. And then node.left is null, so we don't do anything. Node.right is null, so we don't do anything here. And then we will loop through again for our next node, which is 8. So 8 gets removed, and then that is removed from here. So then we get stored into the node, and then we add the value to our sum. So now we get 15. And then node.right is null, so we don't do anything. Node.left is null, so we don't do anything. Node.right is null, so we don't do anything here. And then we are now exiting our for loop because that's it for this current level. And then we also exit the while loop because our queue is now empty. And then we would return our sum, which is 15. So that's how this algorithm works. And then for our time complexity, it's going to be O of n, where n is the number of nodes in the tree, because in BFS, pretty much any BFS and DFS, it's going to be O of n, because we need to visit every single node exactly once. And then our space complexity is O of n or O of w again, because it's just the number of nodes in the bottom layer, which is the width of the tree, or the n divided by 2 in worst case, depending on how you want to express it. So either of these are okay. So that is it for this problem. Thank you guys for watching. If you found this helpful, please like and subscribe. Thanks.